Hi, so now we're going to get ready and talk about the thyroid gland. Thyroid is basically located here in your throat. It's kind of underneath the voice box or the larynx, and it's kind of protected a little bit, or it can be, through connective tissue there. And in fact, I do a type of massage called Thai yoga massage or Thai massage, and one of the moves actually has you go back and forth on it. Ooh, feels weird. And it's actually supposed to stimulate the thyroid gland. So it's just right there, and can be mechanically like moved and stuff. It's one of the reasons that your neck is a little bit vulnerable. You don't want to damage this one. Um, it's kind of interesting with the thyroid gland, and I don't know about you, but I've known many people that have had thyroid gland issues, in that they have hypothyroidism, where it's not producing enough chemicals or enough hormones, and so it's called growth, caused some growth problems and metabolic problems. And it's kind of interesting that the problem is widespread, and it can be highly, the effects of it can be very strong. The reason it's interesting is that there's only 3 different hormones that the thyroid actually produces. It's just that these hormones are really important in the regulation of the metabolic processes of the body. The first one that the thyroid produces is called thyroxine, and or thyroxin. Anyway, so this one has an abbreviation of T4, and the reason it's labeled as T4 is because of the 4 amino compounds that are within the molecular structure. So its nickname directly, or its abbreviation directly derives from its molecular uh, composition. Anyway, so this one is going to be, anyway, so that's one of them. The other one is triiodothyronine. Um, yeah, triiodothyronine. Try and say that one fast. Holy cow. And that one's abbreviated as T3. So you have T4 and T3 within the thyroid gland. And basically what these are supposed to do is to increase the metabolic rate in cells. So they increase energy metabolism and protein metabolism. So they're going to be needed for growth. And yeah, so it's going to be help in development with mental, physical, and metabolic activities. The interesting thing about these guys is that the chemical actually, it consists of a small peptide molecule that binds to iodine. There we go. So it absolutely needs iodine to be able to be produced. And the problem is that the gland itself does not produce iodine. So it needs to come from our diet in order for it to be present within our body, so that when these hormones are being produced, it's going to find the iodine that's already in the body and actually bind with it. And that's how it's then going to be able to travel through. If the iodine's not there to bind with it, it won't actually be released. It's not an issue now for most of us in our country, because we have enough iodine within the salt in order to help us to get a sufficient amount for our thyroid production. And in fact, that's the whole reason we have iodine in our salt. It's not there naturally. We have to iodize it. And so you're actually going to find people in third world countries that have an inadequate amount of salt in their nutrition and in their diet. And so they're going to be developing goiters and hypothyroidism and some other issues. And it's all because of the lack of iodine. So that's kind of interesting. Anyway, so those are 2 of the type of hormones that are being produced in the thyroid, and those specifically deal with cell metabolic processes. So all cells need some of this hormone. The other type of hormone that is produced within the thyroid is much more specific in what it does, and that is known as calcitonin. Calcitonin, you can basically hear calcium within that root, so calcium, calcitonin. Anyway, so calcitonin really is dealing with the level of calcium within the bloodstream, and its whole purpose is to decrease the level of calcium by what it does is actually stimulates osteoblasts. And if you remember, osteoblasts are the cells that are actually in the periosteum, so it's in that membrane that is around the diaphysis of the bone. And these cells will take the calcium from the blood and actually put it onto the bone matrix. So calcitonin is going to stimulate the osteoblasts to work and build bone matrix. One of the reasons that people, when they start to get older, get more brittle bones is that they stop producing as much calcitonin. And so there's just a lot less of the hormone to stimulate these cells to actually work. And so the less control there is, or the less amount of stimulation from the hormone that the osteoblasts do, the less calcium they're going to pull from the bloodstream, which causes the bones to be brittle. So, kind of an interesting effect of age is that it decreases the secretion of calcitonin within the thyroid gland. Okay. And the other thing that's kind of noteworthy is that it needs vitamin D to be able to work.